Here we have a slightly more complicated form of linear equation. Here, instead of only one thing happening to x, two things are happening to x. What is happening to our variable here? First, it's multiplied by a, and then, after that, b is added to the resulting product. So first the variable is multiplied by a, and then b is added to the product. As we shall see in a moment, this equation is easiest to solve if we get rid of b and then of a. So our path is going to be to get into the form something multiplied by x equals a number, and then to get rid of the something multiplied. Let's see an example. Let's say we want to solve the equation 3x plus 2 equals 8. First I want to get rid of the 2, so I'm going to add negative 2 to both sides. 3x doesn't get combined with the negative 2 because those aren't like terms. Positive 2 plus negative 2 is 0. 8 plus negative 2 is 6. Okay. And I can just ignore that plus 0 because it isn't doing anything. Okay. Now I want to get rid of the 3. In order to get rid of the 3, I want to multiply both sides by something. By what? The multiplicative inverse of 3, so 1/3. So 1/3 times 3 is just 1. I'll be left with just x here. 1/3 times 6, that's 2. I get x equals 2. Let's check that. 3 times 2 plus 2, that'll be 6 plus 2, which is 8. Yes. Okay. So that's what happens if I get rid of the 2 first, right? I'm going to show you this example of getting rid of 3 first for demonstration purposes only. Don't use this method unless you have a really good reason to, because in general it's much harder. But let's see what happens. First, I'm going to multiply both sides by 1/3. So on the left side here I need to distribute because I'm multiplying by a sum. So I'll have 1/3 times 3x plus 1/3 times 2. And over here I still have my 1/3 times 8. Actually working out the arithmetic, 1/3 times 3 is 1, so this is just x. 1/3 times 2, of course, is 2/3, and 1/3 times 8 is 8/3. Okay, now I need to get rid of the 2/3. I need to add its additive inverse to both sides. I'm just going to write that as minus, since plus the opposite really does just mean subtract. So 2/3 plus negative 2/3 is just 0. I'm left with just x here. I've got 8/3 minus 2/3, which equals, notice the denominators are already the same. 8 minus 2 is 6. Oh, but 6/3 is just 2. I got the same solution, x equals 2, as before. But the steps were harder. In particular, this step where we had to distribute was just harder because we had to do that distribution step. And furthermore, we ended up with fractions when we didn't need to. So this is a perfectly correct way to do this, but it's the hard way. And when you have the choice between the easy way and the hard way, choose the easy way. Okay, let me show you one more example, just doing it the easy way. So we start with the equation 2/3 x minus 5, which I'm going to rewrite as 2/3 x plus negative 5 equals 7. Okay, so I need to get rid of the negative 5. I'm going to add 5 to both sides. The negative 5 and the positive 5 add up to 0, leaving me with just 2/3 x equal to 12. Now I need to get rid of the 2/3. I'm going to multiply both sides by 3/2. 3/2 times 2/3, that cancels out, that's just 1. I'll get x equals 3/2 times 12, that's 3 times 12 over 2, that's 3 times 6 times 2 over 2, that's 18. We get x equals 18. You're welcome to use your calculator for that fraction arithmetic if you'd rather. And as always, let's check and make sure that was correct. 2/3 times 18 minus 5. 2/3 times 18, let's work that out. That's 2 times 18 is 6 times 3. So that's just 12. 12 minus 5 does indeed equal 7, so that works out.